Okay, session's being recorded.
Thank you. All right, hello, everybody, and thank you for joining us. We're glad to have everybody with us tonight. This topic got a lot of interest. We've done a few seminars each year, and this has probably gotten the most attention. We did a presentation on heat pumps a couple of years ago as kind of an introduction in advance of rolling out some new energy efficiency programs. But we wanted to let you know tonight that we're actually enhancing our efforts in this area specifically. And we've also partnered with a company called ABODE, which has a great deal of expertise in this field. And they're going to talk a lot about heat pumps themselves and also about our new program. So I just wanted to take a minute to kind of go through what we're going to talk about tonight. WMGLD as a whole, I think we've taken a lot of steps in the past few years to really improve on our energy efficiency offerings. We did a survey 2.5 years ago of our customers, and we got very high ranks in a lot of areas around fiscal control and operations. And the place we didn't get as high rankings, although pretty good, was our energy efficiency program. So we really embarked on an effort to improve those. We rolled out a new set of programs at the end of 2019, and we really tried to enhance our offerings significantly, as well as bring our rebates competitive with the entire marketplace. So right now for our residential customers, as always, we've offered the Muni Helps home energy audits. And we view that as the key beginning step and first step to everything that we do. We really need to give the customers the opportunity to look at their homes completely before deciding what to make improvements on. So we really strongly encourage, and those are, home energy audits can be reviewed and updated probably at least every 5 years. It's not a bad idea to get a new audit. And the home energy audit is a prerequisite for many of the programs that we're going to talk about. Not all of them, but many of them we're going to talk about tonight. And one of the other key programs we have for residential customers is our appliance rebate program. That's a direct appliance rebate, and that's based exactly on the appliance that you buy, based on its efficiency. And there's a lot of information about that online. That is one of the programs that does not require an energy audit. So you're not required to get an energy audit, but you do have to have an energy efficient appliance that meets certain criteria. And the criteria vary based on the appliance. So we strongly encourage you to check our website for the different appliances, refrigerators, air conditioners, everything that is listed on the website. We also have made a strong move to the Wi-Fi thermostat and thermostat control programs. The Wi-Fi thermostats are obviously growing in popularity and are widely available now, and we strongly encourage folks to do that. And they also tie with our kind of connected homes on demand services, demand management services that we now provide. Many of the retail and popular thermostats like Nest are part of our connected homes program. So again, we strongly encourage you to look at that. We also offer a home energy monitoring product called Sense. It's very inexpensive relative to other devices like this on the market. You can monitor your entire home energy usage. What it does is it identifies profiles of different things in your home that use energy, and it helps you manage those use. For those of you that are interested in electric vehicles, we offer a charger program. We provide a free level 2 charger for anybody that wants one. However, the key is that you have to agree that we will be allowed to control it during peak times. So in most cases, what would happen is that if you came home from work and you plugged it in, we might delay the start of the charging till after the peak hour. And that's not all the time, but that's some of the time. And when we do that, it really doesn't have a major impact, but that's what enables us to control our overall peak. So that's very important. We have a solar incentive program that we've been offering. We extended it into this year. And so we do have some money still left in that program, and we strongly encourage anybody that's considering solar to act quickly on that, because that program is budgeted year to year. It's been supported by the state in the past, and right now we've supported it internally, but we do have a limited amount of funds on that. So if you're interested in that, please move relatively quickly. We have an incentive rebate program, which allows customers to act on some of the things that are identified in the home energy audits, such as insulation and more energy efficiency upgrades that you can make to your home. And then finally, last year, we rolled out a heat pump rebate program, and that's what we're going to talk about tonight. So we're really here to talk about that, and I think that's going to be a valuable conversation. Just a little bit for those that are familiar with our commercial programs. We've started a commercial program this year. It's Green Energy Opportunities for our larger commercial size customers. And for those customers, we're really looking for more customized approaches, but also there's some standard approaches. So I encourage anybody that owns a commercial business in Wakefield to take a look at that. We also still offer them solar incentives, and we also are willing to discuss custom programs on a case-by-case basis if there's a unique opportunity to save energy, and we can work with you. So those custom things are not the standard lighting rebates, or it's more custom things. So tonight we're pleased to start to talk about our air source heat pump program. It was added to our offerings last year, and this year we've really enhanced it. We've improved the incentives levels, the structure of the program, and most importantly, we've partnered with ABODE. And ABODE has a great deal of experience in this market, and we really are going to rely a lot on their expertise in terms of one of the key problems with heat pumps has been that they're improperly sized or that they're underutilized when customers install them. So one of the things we'll talk about a little bit about tonight is making sure that you properly size it and that you utilize it correctly. And we've already had customers telling us that they only really got it to do air conditioning, but you're really missing out on a lot of the value of the heat pump itself. So we really want to try to use ABODE as not only a service that will help us identify whether you qualify for rebates or not, but also to provide some guidance to make sure you're doing it right. So I think this is a huge value added service that we're offering this year. And we wanted to invite them tonight to talk a little bit about who they are, what they offer, and how our new program has changed. So I'm pleased to welcome Ryan Keith and Chris Haringa. They're going to talk a little bit more now about our new program. So, please keep your mics muted. We're going to stop a couple times through the presentation to open it up for questions on each section, and then there'll be obviously ample time for questions at the end. If something comes up in the middle of the presentation and you'd like to offer a question via chat, we'll make sure we're monitoring that as well. So we'll keep an eye on the chat screen if anybody is interested in putting a question through at that point. But again, we'll stop through the program to make sure that we're covering the important information. So without further ado, I'll turn it over to Ryan and Chris.
Thanks, Pete. So hi, everyone. Thanks for joining us this evening. My name is Christopher Haringa. I am the program manager here at ABODE for WMGLD's Air Source Heat Pump Rebate Program. And so tonight, the overview is as follows. We're first going to be covering air source heat pumps kind of 101. Then we'll have a Q&A session about the technology. And we'll then cover the rebate process and the amounts. And then we'll pause again at the end for a final Q&A session. So let's get started. First, I want to tell you a bit about ABODE. We're a small local business based out of Concord, Mass. We provide community heat pump programs for 7 other MLPs currently. And since launching this program last year, we've connected with well over 250 households to help them learn more about heat pumps. And we've conducted technical reviews on over $1.1 million in projects. We don't sell heat pumps, although we used to be contractors ourselves. We are a third-party objective team that provides advice to customers, contractors, and utilities around clean heating and cooling solutions. We also oversee a large portion of the Mass Save program on behalf of National Grid, specifically residential customers that use home performance contractors to access no-cost Mass Save energy assessments and incentivized weatherization benefits. In Connecticut, we work with Eversource to support contractors offering virtual pre-assessments as a way to help residents access the benefits of the energized CT in a safe way. Here are many of our clients. As you can see, we're working with many MLPs to support the adoption of clean heating and cooling technologies. So our background as contractors, program administrators, utility consultants, and lead vendors gives us a unique perspective on the goals of each of these different stakeholder groups. And we're also customers in these programs. Being able to evaluate every situation with each of these lenses enables us to support folks throughout their whole project. Even on the right here, this is a photo of our VP of operations doing a deep energy retrofit on his own home a few years back. So many of us like to get our hands dirty as well. So as Pete mentioned earlier, one of the biggest ways ABODE that can help residents is through the no-cost conversations provided by WMGLD through ABODE. During these consultations, we'll work to understand your goals, motivations, and your home's needs so we can help you make an informed decision with confidence. Through these consultations, we're happy to cover whatever your needs are, whether that's a general conversation about what heat pumps are and how they work, or if you need some support evaluating multiple bids, we're here to help. At the end of the day, we want you to be prepared to move forward with a heat pump contractor of your choosing if it makes sense. The upfront advice we provide is intended to be starting point for most folks, and your contractor who is in your home taking real measurements, doing load calculations, and assessing the site conditions should be best situated to properly size and design a system that meets your needs. And when you have questions though, we're always here to help. So now we're going to take a look at heat pumps in a bit of detail. So let's start with how do these things work anyways? A heat pump is a versatile, efficient cooling and heating system that operates using electricity. Heat pumps do not burn any fuel. They move heat from one place to another. So to provide heat, a heat pump works by extracting heat from the outside air of your home and transferring it to a refrigerant. And they can do this even when it's very cold outside. The refrigerant is then compressed, which increases the temperature significantly. The hot refrigerant is then moved to the indoor unit of the heat pump, which then passes air over the hot refrigerant and transfers it to your indoor air. When in cooling mode, a heat pump and an air conditioner are functionally identical, absorbing heat from the indoor air and releasing it through the outdoor unit. When in cooling mode, the refrigerant moving to the indoor unit of the heat pump is very cold, transferring cool air to the space. This chart shows the breakdown of the year built of homes who have adopted heat pumps in our programs. For example, of the homes that have installed heat pumps, 23% were built between 1941 and 1960. The same percentage of heat pump adopters had homes built between 1961 and 1980. And so you can see here in the rest of this chart, homes of all ages and sizes are adopting air source heat pumps. 67% of homeowners purchase heat pumps to reduce or stop using their fossil fuel system. Here we can see how much of the home heat pump adopters are typically conditioning with heat pumps. This doesn't mean they have removed their old heating systems, but that the heat pumps they installed service or condition that percentage of their home's square footage. So for example, 34% of homeowners are choosing to condition 100% of their house with heat pumps. 89% of heat pump adopters keep their existing system in place. It may run at the same time, but heat a different area than the heat pumps, or it could be used as backup. So let's take a look at the operating cost of heat pumps in WMGLD's service area. This chart uses WMGLD's residential cost of electricity per kilowatt hour to represent the operating cost of an air source heat pump during the heating season. It uses 15.6 cents per kilowatt hour as the all-in rate for residential customers, and it also uses WMGLD's natural gas rate per therm. Heat pumps are 2 to 4 times as efficient as a gas furnace, even in the coldest climates. This technology has come a long way from traditional electric heating and offers efficiency that fossil fuels cannot match. Air source heat pumps deliver heat at progressively lower costs the warmer the outdoor temperature. As you can see in the chart, we spend about 80% of our heating season between 32 degrees and above, and only about 20% below freezing. The overall average of the season is represented by the green bar with the arrow. The bars following it to the right show the costs depending on the outdoor temperature. As you can see, it's highly cost competitive against all other fuel types. While some customers opt to keep their existing system for days when it's extremely cold, many households will use heat pumps year-round and are still very comfortable. Noting the value of cooling as well, air source heat pumps are extremely efficient at providing cooling in the summertime. On average, heat pumps are twice as efficient as window ACs, and many models offer improved efficiency over central air as well. So a few key points to remember. First one, air source heat pumps operating cost is cheaper than oil, propane, wood pellets, and electric resistance. And second, the cost of electricity is much more steady and predictable compared to fossil fuels over time. So this chart examines how many tons of CO2 emissions heat pumps versus traditional heating systems create over the course of 20 years. Including emissions from the fuel, heat pumps have the lowest emissions. However, heat pumps operating emissions are technically indirect. Air source heat pumps have no direct emissions from the operation of the unit itself, whereas fossil fuel systems burn fuel at the unit and have direct emissions from operation. This chart uses New England's electricity generation mix to calculate emissions for heat pumps. The cleaner the electricity is produced, the cleaner air source heat pumps will become. If you are purchasing solely renewable energy, or if you have enough solar at your house, your operating emissions will technically be zero. WMGLD's electricity generation mix is even cleaner than the representation above. So operating a heat pump in WMGLD service area will have even lower emissions. Plus, another nice thing about being a customer of a muni-like plant like WMGLD is they have the opportunity to be more progressive and expedite the adoption of cleaner energy versus larger entities. So a few key points to remember for this one. Energy production is getting cleaner year after year, which means heat pumps and carbon emissions are also reduced year after year. And heat pumps over the lifetime of operation have the lowest emissions. So we're seeing a real diversification of the kinds of configurations of air source heat pumps. So we'll go through a little bit of that. Air-to-air heat pumps, or heat pumps that use the air outside to heat or cool the air inside, are the biggest share of the market today. This has been driven by the growth of ductless air source heat pump systems, or ductless mini splits, you may have heard them called. That's probably what most of us are familiar with and have seen it in homes, shops, or restaurants in the area. So that is just one of the configurations that you can use in the air-to-air category. You can use more traditional centrally ducted systems. You can use one-to-one systems that are just one outdoor unit with one indoor unit, like a ductless mini split. There are even multi-zone systems now that you can match one outdoor unit with multiple indoor systems. And there's everything in between in terms of combining the different indoor units, and we'll talk about that in a minute. So a few reasons why air-to-air is the leader. The install for ductless units is quick and relatively straightforward. They're versatile and compatible enough to work in most homes to offset or provide all of your heating and cooling needs. And they're lowest cost to install compared to other types of heat pumps. Another opportunity is air to water. So using the same technology, but transferring that heat throughout the home with water, with hydronic systems that use baseboards, radiators, or radiant floor heating. There's a lot of really cool opportunities out there with new construction, but some challenges on the retrofit side with retrofitting existing hydronic systems. The hot water generated by air to water heat pumps is not as hot as the water generated by traditional boiler systems. The lower temperature water from the air to water heat pumps requires a different type of hot water baseboard or radiator to keep the house warm enough when it is cold outside. So it's not always a good fit when trying to replace a boiler, and you can still consider air-to-air heat pumps as an alternative. As this technology develops in the years ahead, we will likely see this becoming more of a possibility. There are other types of heat pumps more on the water side, such as geothermal or ground source heat pumps. Similarly, you're harvesting that energy from the ground or from the water, and you can distribute that into your home in multiple ways, whether you're doing it through air handlers or through hydronic systems. So there are a lot of ways to mix and match this technology depending on your needs and preferences. But today we're focusing on air-to-air heat pumps. So now let's focus some more on the types of indoor units that you can use with air source heat pumps. Ductless units are versatile enough that you can size them to heat and cool large open areas or even small bedrooms or offices. There's a lot of form factors when it comes to the ductless systems, starting with the wall hung unit on the left that most of us are familiar with. You can get a floor mount unit that looks a little bit more like a floor radiator, at least in where it would sit, and then the ceiling cassettes on the right that go in the ceiling. The bottom picture in the ceiling cassettes category is a bit of a newer product that does a better job of fitting in between the joists in the ceiling, which was previously an issue in terms of fitting some of the ceiling cassettes. Again, there are new technologies coming out all the time to make installing this technology very practical. We're also seeing more and more ducted systems, mini ducts, and compact ducts. We've got a lot of different names, but essentially the mini and compact ducted units can be set up with some amount of short run ductwork that allows you to use one unit and pack a few different smaller rooms. These can be really handy to use in parts of the home where the bedrooms and bath are located, so that each room doesn't require a ductless unit. These units are growing in popularity, but the industry is still a little more comfortable with centrally ducted units. We're here to help you find the right contractor if these make sense for your home. These units range from the low static product on the left that can only probably serve 1 or 2 rooms to a higher standard product that can serve a whole floor or 3 to 4 rooms, maybe about 800 square feet or so. And finally, on the right, a more traditional high static centrally ducted product that can serve a whole house. You can see here, there's a lot of variety on the design side that you can leverage to find a solution that makes sense for your home, both functionally and aesthetically. You can mix and match what you have in your house, and a design that is growing in popularity is to use a compact ducted unit for the bedrooms, bath, and hallway part of a house, and a ductless unit to serve the more open living area of the home. It's important to articulate your goals and motivations to a contractor well, so that in turn, you can get a quote for a system design that meets your needs. So thinking about that, is your goal to save money, increase comfort, reduce your carbon footprint by reducing fossil fuel usage? How much of the home are you trying to heat? Do you plan to keep your existing system? And if so, how often do you want to still use it? If you plan to heat and cool a substantial portion of your home with air source heat pumps, it's important to ask your contractor if they will run a heat load calculation rather than just use rule of thumb. Sizing heat pumps correctly from heat load calculations reduces the risk of performance and efficiency issues. If you will keep your existing system running in tandem with an air source heat pump, it's important to consider how the existing heating zone will interact with the area the heat pump will condition. There are a number of good strategies to address this, including integrated controls. Integrated controls are thermostat systems that can talk to your heat pump and your existing heating system. If integrated controls won't work for your specific scenario, there are other ways to stage the existing system and the heat pump so they work together instead of compete with one another. As we've learned a little so far, there are many ways to design these systems to meet your needs. You can leverage the different types of indoor units to match the needs of the space you want to condition. Open floor plans work great with ductless units, and 1 or 2 heads can condition a large area. Compact ducted units can service areas with isolated rooms, and small single zone units are great supplemental heating and cooling additions to cold or hot areas of a house. You can connect multiple indoor units to one large outdoor condenser, or break it up into multiple smaller outdoor condensers to improve the control and efficiency. As I hinted on the previous slide, there are some pros and cons of single zone versus multi-zone units. Single zone or one-to-one units are incredibly efficient at both heating and cooling. The outdoor condenser can connect to a ductless unit as shown, or a ducted unit. Depending on the size of the outdoor condenser and the type of indoor unit, you can condition a very small room to a whole floor. Single zone units offer excellent control and comfort. Multi-zone units, or 1 to 3, as shown in the image above, can also be connected to ductless, ducted, or a combination of indoor unit types. Still providing excellent efficiency when heating or cooling, these units can handle multiple rooms, floors, or the whole house, depending on how they are configured. While one multi-zone unit could be configured to have enough indoor units to provide a solution to the whole home, manufacturers encourage best practice designs that break up the responsibility to multiple outdoor condensers rather than one. This can increase efficiency, control, comfort, and reduce the risk of any performance issues. So we've learned now that air source heat pumps come in a variety of shapes and sizes. Depending on your home's needs, the design that is appropriate for your home, and your goals as the end user, the cost can vary greatly. For small ductless systems that may serve a small to medium-sized room, you may see a cost in the realm of $3,000 to $6,000. For systems that are designed to service the entirety of a large home and provide all of your heating and cooling needs, and may include installing new ductwork, costs can exceed $30,000. So it's important to remember that your operating costs will vary depending on system design and the outdoor temperature, as we discussed in a previous slide. If you're looking to displace an oil or propane system, you're likely going to save a lot of money. If you're looking to displace a highly efficient natural gas system, your operational costs during the heating season could be minimal, but it depends on many factors. So you're looking to see, with most fuel types, some amount of savings throughout the heating season. Heat pumps are different than traditional systems like boilers or furnaces. And there are a few things you may need to unlearn about how to operate them effectively and get the most out of your new investment. So here's 7 don'ts for heat pumps. So don't worry about the temperature reading. A heat pump measures ambient room temperature differently than your old heating system. Set your heat pump to a comfortable temperature, then adjust the setting up and down over the course of a few days until you've reached the temperature number that feels right to you. So pay less attention to the number on the thermostat control and just find what's comfortable, is what that really means. So in the area that you're using your heat pump, you could turn your old thermostat maybe 6 to 10 degrees lower than you used to. If you used to set it to 68, turn it to 60 degrees or something like that. This allows your old system to become technically the backup heat source. If the area gets chilly during a severe cold snap, don't be afraid to turn up the old thermostat temporarily. This way you can maximize the use of your heat pump and see how much it can do. Try to keep the doors open to rooms without the ductless unit, allowing the heat pump's heat to circulate as much as possible. So that strategy could vary greatly depending on your home, but if you're trying to displace a specific zone of heating, that could be a good strategy. Number 2, don't fuss with it every day. You may have lowered the temperature on your old heating system when you went to work or at night. A heat pump is a bit different. It reaches peak efficiency by maintaining a set temperature. Find the right setting and then leave it alone and let it work. There is an exception though, so for absences over 24 hours, you can go ahead and turn the temperature down. Number 3, don't go easy on your heat pump. The best way to benefit from a heat pump's superior efficiency is to use it for as much heating as it can handle. Experiment by opening a few doors to expand the zone and then turn up the fan. You might be surprised how much space a heat pump can actually heat. Number 4, don't use auto mode. It's natural to think auto mode would be a more efficient setting, but if you use it, your unit runs the risk of toggling unnecessarily between heating and cooling. Your heat pump will run most efficiently while set to heat in the winter and set to cool in the summer. But note, auto fan function is a separate setting and perfectly fine to use. Number 5, don't use the lowest fan speed. Strange but true, a heat pump works most efficiently when set to a higher fan speed. Of course, high fan speeds can produce more ambient noise and air movement. So use the highest speed you're comfortable with and then dial in your preferred temperature and refer back to number 1 there. Number 6, don't forget to keep up on maintenance. This is true for most any heating system, but that doesn't make it any less important. It's generally quick and easy to do, and you should consult your heat pump's user manual for details on cleaning and replacing cartridges. You will generally need to clean the indoor unit filter every 2 to 6 weeks, depending on use. And you want to keep the outdoor compressor unit free of debris, snow, and ice. And hire a qualified professional to service your heat pump every year or 2. And you want to see your heat pump's manufacturer guidelines for the maintenance interval. And for those of you that may have ductless indoor units, those filters are really easy to clean and only take a few minutes, and they're reusable. Number 7, don't worry about an ideal swap over point. And what is a swap over point? It's the exact temperature below which it costs less to run your backup system than your heat pump. But it's not easy to figure out since it depends on backup fuel, heat pump model, electricity rates, and many other factors. So use your heat pump as much as possible. Unless your backup heating fuel is very affordable, like we saw with natural gas, they're pretty close when it comes to the season average. There aren't enough super cold hours in the year for your heat pump in cold weather to make the swap over point really worrying too much about. So if you have a system that's designed to displace a whole zone of your backup heating, even if it's natural gas, you might as well just stick with the heat pump. So these tips we covered help increase efficiency and operating costs. It's important to understand how your new heat pump works and how to operate it efficiently to get the most savings. So now we're going to take a quick break for some questions so far. So at this point, if there are any in the chat box, I think Ryan will provide those to me.
I don't see any in the chat yet. If anyone has any they'd like to ask out loud, feel free to use the raise hand reaction and then we can go from there. And give it another few seconds here, but I'm not seeing anything yet.
Chris, you're doing such a great job. There's no questions. Oh,
All right, well, that's a good question. How do I get started? So we're going to dive into the specifics here of the process with WMGLD's rebates and the process of speaking with ABODE for a consultation. So I think that is a great segue into our next part of the presentation here.
Yeah, I'm not going to segue just yet, just in case anybody else has any questions, but my advice would just be how to get started. Set up a conversation with us at ABODE and we can get you started, fill you in on any of your questions and help you feel ready, prepared to have some contractors come through for some quotes. And I'll show you at the end the link to get that started up.
Chris, there was one question about the size of electric service that's typically needed to, with 100 amp service, do you need a 200 amp service?
Yeah, it really depends on, like the space left on the panel. So if you have 100 amp service, but you still have some capacity left on that you could use, you may not need to upgrade your service panel. But many times people are doing that as part of these projects. And honestly, looking ahead, a lot more of the home, just everyday things are going to become electric, such as the car, your lawnmower eventually. All kinds of stuff is going to become electric. So it's going to be an eventual upgrade many of us will have to do eventually if you presently have a 100 amp service. I got the chat box open here, Ryan, so I actually see the question. So we got a question. Do you replace the filter every 6 weeks or do you clean it? With the ductless units, you just clean it. So these are just filters that you open up the unit and you'll take it out, bring it over to your sink, just wash it off, clean it out, let it dry, put it back in the ductless unit, close it back up, and you're good to go. It doesn't take very long. It's easy to do. And depending on your house, the interval at which you clean them could be 6 weeks. It could be longer, could be shorter. It just depends on your house. So can you speak more about the cost of maintenance? How does it compare to other heat sources, i.e. a boiler, etc.? The general costs to do maintenance every year for these systems, what we're seeing, it can be pretty much right in line with the same sort of costs that you were seeing to maintain your boiler or your furnace. So I talked about some refrigerant. Does that need to be replaced or maintained, and how often? So that all comes down to install. So a good quality install is key, and that's why you want to work with a good quality contractor, and that's why we create the participating contractor list that we'll touch on shortly. Having a quality install will mean that all the connections and everything, all the tubes that have the refrigerant in them, the refrigerant stays in them and doesn't leak out. And so it really comes down to a high quality install. So theoretically, if the install is high quality and good, and everything's nice and tight, you shouldn't have any refrigerant leaking out. It does happen though occasionally as the systems get older and older and older. And that's why regular maintenance is so important to make sure you keep on checking on those things. And the next question, I don't have great installation. Should that be fixed before I jump into heat pumps? Yeah, weatherization and heat pumps are like best friends. If you have a house that is well air sealed and insulated, that's only going to help the heat pumps work efficiently for you. Like we touched on earlier in the presentation, heat pumps like to maintain a specific temperature in the house and just kind of quietly hum along and keep you at that comfortable temperature. And so if you have a house that is losing a lot of heat because the house is pretty leaky and doesn't have much insulation, the heat pumps won't be able to operate as efficiently. So my recommendation would be get a home energy audit through the Muni Helps audit, which is free through WMGLD. Talk to the auditor, see what kind of weatherization there is, take advantage of those programs through this Muni provider and get the installation. And you can in parallel talk to us about what heat pumps might make sense for your house. Next question. If I have steam radiators, does this mean I have to replace them if I want to use air pumps to heat my house instead? I want to upgrade, but don't want a major cost. It's a great question. So you can leave your existing heating system in place. You don't have to rip it out by any means. A lot of people, I think it was like 89% of people right now are keeping their existing system in place while they start adopting air source heat pumps. And there's an approach that I would call the start small approach that I really like. And if you decide to just kind of do maybe one area of the home, like the main living area that you use all the time, and maybe you have a zone of heating in that area as well, you could get a single zone ductless mini split in that space, and that could displace all the heating in that area. It'll probably provide all the cooling in that area that you need. And as you get used to it, see how much it can do, you can build on that in the future and continue to add more heat pumps in other areas of your home. And if your eventual goal is to get off of the steam system or whatever fossil fuel system you have, you can do that over time, and that works perfectly fine. All right, so for systems with ducts, do you need to purchase and replace filters multiple times per year? Are the filters expensive? So it depends on the type of filtration system that you have. There's really fancy ones. There's just kind of like regular ones that have the little filters that kind of go in and out of a slot. And so it's going to be really comparable costs to your existing ductwork that you have most times. So the filters, it depends. There's kind of a scale. There's kind of standard filters, and then there's MERV filters at the high end. So whatever you're probably used to seeing for expenses, it would probably be relatively similar. Nothing too new in the way of the type of filters they're using. It's pretty typical compared to the existing type of traditional ducted systems we have.
Chris, on Dave's two questions, why don't we do the second one and we'll deal with the first question after the second half of our presentation.
Okay. So tips on maximizing heating efficiency using a heat pump as an alternative source, such as a furnace, would be great. So yeah, I would refer to the slide we had here previously that we were looking at. This is some of the best ways to try and maximize the use of your heat pump and try to get the most savings out of it and the most comfort and such. So some of the big ones here are going to be trying to make sure that your existing heating system is not competing with the heat pump. So trying to stage the two systems, that's a good one. And the other one is do not do temperature setbacks overnight. So that's actually going to increase your cost with using the heat pump. So they like to maintain a specific temperature. So try to do that instead of turning it down 6 to 8 degrees overnight, like we are very used to doing with our fossil fuel systems. Does the contractor installing mini splits cover from the electrical services to increasing the amps? What about the outlet, 110 volt or 220 volt old houses with fuses? And so I'm not an electrician. I'm not an expert on all that, but generally contractors work with electricians or have them on staff who install air source heat pumps. And so many times you can have all that just wrapped into the cost of the project, or they can have their electrician provide you a quote. I've also seen it where people use their own electricians to hook up the system and do all that as well. So there's different ways of going about it.
Great. Well, why don't we keep going? We'll start to talk about the specific, and the question about recently installed, hopefully we'll cover that as we go through the second half of this. But we'll also open it up again at the end for questions about our program or more questions about heat pumps themselves.
All right. So just want to reiterate that WMGLD strongly recommends scheduling a consultation. It's one of the best ways we can help you out, and it's free. And it's great to be able to talk to you, understand your goals, your motivations, and your home, so we can give you good information, some good resources to help you make a decision that's right for you and your family. So I can't more strongly recommend setting that up. And so, through these consultations, we're just trying to understand and cover what your needs are, whether that's a general conversation about what heat pumps are and how they work, or if you need some support evaluating multiple bids, we're here to be an impartial third-party body and just help talk about the facts, help you understand things. And as I mentioned before, the contractor who is on site, taking real measurements, doing the load calculations, like we've mentioned, are important, and assessing those site conditions. Those folks are the ones that are best situated to properly size and design a system that meets your needs. However, we're still here to help you evaluate bids, understand things, and take a look at all that information to help you kind of parse it all out and see what's right for you.
And Chris, it was nice your brother-in-law chimed in that middle comment.
That's right. All right. So as part of this program, we curate a participating contractor list. There are a lot of contractors in the community, and despite our best efforts, they may not be on the list, but we're here to engage with them and explain how to file for the rebates. So we're not directly endorsing any contractors, but contractors on this list have passed an application process. We check to make sure they have attended relevant manufacturer trainings for the products they install, checked references on their work, and they have committed to provide high quality customer service to operate in the program. They're also familiar with the pre-approval and install QA steps of the process that we'll touch on in a minute. So, you know, customers are not required to use contractors on the participating contractor list. As long as the pre-approval and install QA steps are followed by your contractor, you can still receive a rebate. Contractors on the participating list are already familiar with that process. So let's touch on those key steps. So in order to receive a rebate, your contractor must submit a pre-approval form to installation. So prior to installation, this form is submitted. And then there is an install quality assurance form completed after install is complete. Many times it's submitted the same day, everything is done while they're on site. The pre-approval form is where the contractor submits information about the home and system plan to be installed. So when we receive the pre-approval form from the contractor, we'll consider, is the equipment reasonably sized for the space being conditioned, the type of floor plan, and the building envelope? Is the equipment selected appropriate for the type of floor plan and intended use? And are we optimizing runtime and use? If those all make sense, we'd approve the project. Install QA is used to ensure systems meet best practice installation guidelines for cold climate air source heat pumps. So providing key photos of the installed equipment and the site conditions. They're going to respond to attestation questions regarding the steps of the install, so we can verify how it was done, look at those pictures, just make sure everything looks good in that regard. And at the end, surveys are used to ensure participating contractors and contractors in general that are working in the program are continuing to provide great customer experiences, and we strongly encourage customers to complete them. So taking a look at the rebate amounts and efficiency requirements. So for central heat pumps, multi-zone mini splits, and ducted mini split heat pumps, the efficiency requirements right there are for the SEER is 16 minimum and HSPF is a 9.5 minimum. It's slightly higher for single zone mini split heat pumps, which is easy for them to achieve. And the SEER is 18 and HSPF is 10. And there is $500 per ton up to $2,000. So what that means, actual tons are calculated off of the AHRI cooling capacity. The AHRI cooling capacity is off of the certificate. The AHRI certificate is a third-party agency that rates the efficiencies of units, and so it's a great place to look for a rating that all heat pumps have. And so when you are applying for a rebate, WMGLD will refer to the AHRI certificate, look at the rated cooling capacity, divide that by 12,000 BTUs, and the rebate amount is based on those actual tons. So if the rated cooling capacity for a given unit was 36,000 BTUs, that would be 3 tons, and the rebate for that unit would be $1,500. All right, so that's the quick on the rebate program. So here is a link to get to WMGLD's page about the air source heat pump rebate program. And to schedule a consultation, if you go to that link below there, you can set up a consultation with us. It's about a half-hour conversation, and you can find some spots that are convenient for you. If you can't find one on the calendar presently, you can fill out the link right in the description there to just send a message to us directly, and we'll try to schedule you as soon as possible with one of our heat pump specialists. So at this point, if anyone has any further questions, I'm ready to take them.
Chris, getting back to that other question that was on Dave's list. So the program officially went into effect May 1st. So anything that was prior to that did not have to meet the requirements that you've outlined. So therefore, anything that was prior to May 1st. But anything that's happening this month, we're going to treat it as if it's in the program, and we're going to try to catch people up that if they've started the process this month.
So yeah, we will post the PowerPoint, the presentation, all of that will be posted by WMGLD.
And the recording of the entire session will be available on our website as well.
So a question for you, Pete, how long will this program last?
We renew our budget for our programs every year. I don't see the programs like this going away. I think one of the goals of the WMGLD is obviously an environmental goal, and we feel that heat pumps are consistent with that approach. So we don't see that changing in the short term, but our current program is funded for this year. So it's good through the whole year. But again, we set the budget for the program each year, but I wouldn't envision that this would be one of the things that would be at risk of going away. It would probably be more likely that over time we continue to expand its offerings. And there
Next
is
question.
there's a limit per customer per year of $2,500 of total rebates, including insulation, heat pumps, and Chris talked about the specific limits around the individual heat pump units.
So the question here is the rebate maximum per unit or per property? So in that instance question there, it would be per property. And as Pete just said, the total maximum cap for all rebates available to a customer per calendar year, is it correct, is $2,500. All right, next question is, we bought 2 indoor heat pumps last year, but they have not been fully connected. Could we still get in the program? So that's a little tricky. If it was installed prior to May 1st, I think WMGLD wants customers to go through the previous program. But I guess I would leave that question to kind of Pete, or maybe it'd be best if you called WMGLD up to kind of have a conversation offline about that one.
Yeah, I mean, so we did have a very generous program in effect last year as well. So this one's obviously more enhanced, and it's also tied to the sizing and consultation that's required through ABODE. So that's why we have some of the enhanced benefits. But if you haven't already, you can call us and we can talk about where you stand on your project and what's required and which rebate you would qualify for.
I have another question from Martha. I would also encourage you to call Wakefield Municipal up and have a conversation about that. And then the next question, is the rebate reimbursed or given as a credit to the WMGLD account?
It's a bill credit. Are there any other questions? I really appreciate that. This is has been a very active, obviously it's a very interesting topic. It's a way that we're moving forward. One of the things as a utility that's fairly important to us is that we look at our entire portfolio, which includes our gas portfolio. And one of the things that, even as Chris talked about, one of the things that is that you may not choose to remove your existing system, but rather supplement it. And if you choose to do that, and most people in existing homes choose to do that, they'll keep gas in place. But a product like this helps us curb our peak gas usage, which saves all of us on our gas costs as well, because our gas costs are hugely driven by that peak. So to the extent that we can manage the peak of our gas usage, we are definitely benefiting yourself and everyone. So that's another benefit to installing heat pumps, even if you're going to keep your existing gas system.
All right, I don't see any further questions coming in. So I want to thank everybody for attending. I'm looking forward to speaking with some of you, or all of you, if you all sign up. And we're glad to get this program up and running, and excited to see a big difference in Wakefield to try to get as many people adopting air source heat pumps as possible.
Great. Thank you very much. to everybody that joined us tonight, and to Chris and Ryan for helping us out. We really appreciate it. And we're looking forward to what's next. Thank you.
Thanks, everyone.